Hi class, my name is Idel Perez and I'll be showing you guys how to do caramelization at home. And my main inspiration for this is getting out of October season and being exposed to a bunch of candies and just wanting to see how caramel works and how chemistry can be incorporated into that. Okay, so before I start, I have right here on my computer where I will be taking my data, but also a list of the concepts for chemistry that can be incorporated into the caramelization. I have it right here in a Word document, but some of the concepts are sugar decomposition, and that's a result of chemical reactions taking place, thermochemistry, because of the energy and heat absorption, molecular structure, how different bonds break and reform, and the changes in matter. So the sugar melting and resulting in liquid caramel coming from solid to liquid. Okay, before we get into making the actual caramel, here are my set of ingredients. We have sugar for the main pour. We have a measuring cup so that we can measure how much water or milk we put into our pan. We have salt for flavor. And we have butter and milk because I didn't have heavy cream, and this is another substitution. But yeah, we have a wooden spoon. I highly recommend using a wooden spoon because if we use something like metal, it'll be easier for it to conduct the heat, and this will help insulate it more. Okay, the very first step to making caramel is to gather together the sugar. Right here, I'm gathering together 1 cup. Since my measuring cup was a little small, I have to do 2 rounds of these. But once I have my sugar in, my next step will be to add water. And as you can see in my next step, I have a cup of 3/4 cup of water, and then I'll heat up my pan so that it can melt. Okay, this is what it looks like when I had barely added the water and the sugar is just about to melt. We're about 5 minutes in and the bubbles are starting to form and the sugar is just settling in. 10 minutes have passed and more bubbles start to come in. At around 15 minutes, the amber color started to set in, so I decided to take in my wooden spoon and start mixing it in. The process of caramelization requires a lot of heat in order for the energy to break down molecular bonds. Each stage of browning that happens corresponds to specific energy thresholds where new reactions come in. Overheating might cause carbonization and it'll cause blackening and the taste won't be as good. Right here, the color turned darker and it's just about the perfect shade for the caramel to be put aside. Once the hot pan was set to the side, I added 3 tablespoons of sugar and slowly started to mix that in. Afterwards, I added a 3/4 cup of milk and sorry for the spilling, I slowly started to mix that in as well because steam started to form and I didn't want to burn myself. I got a sweater because I didn't want to burn myself, so yep. Alright guys, this is what the final caramel looks like. Super creamy, super moist, the best texture ever. Just kidding, this is not the caramel. This was the caramel I ended up with, but hey. Okay, ideally this table shows what the caramelization process would have looked like. So at 100 degrees Celsius or so, there should be like a clear syrupy type of texture, and this is when the water evaporates, causing a physical change, right? The composition hasn't changed fully, so it's a physical change. At 160 degrees Celsius or so, the color will change to a light golden, and this is the step where the sucrose breaks into the glucose plus the fructose. This causes a complete change, which in turn causes a chemical change. At 170 degrees Celsius, amber type of color starts to appear, and this is where the formation of caramelins starts to appear, and then this becomes a chemical change. At 180 degrees to 200 degrees, there should be a dark brown color, and this is a further breakdown of bitter compounds, and this is when the caramel compounds are starting to come out, and this causes a chemical change. At black, if you see black, which mine was very close to becoming, whoops, let me put that back. Then this means that something was burning, thus creating a complete chemical change, meaning it was irreversible. You can't go back. You burnt your product. But yeah, this was close to what my outcome was. But mine was dark brown, which because of that, the flavor was bitter and it didn't come out as I'd like to. The consistency wasn't as smooth. It was very rough, but yeah. While editing this video, I just realized that I had said the caramel compounds start coming out when the color starts to appear dark brownish, but in reality, they're supposed to appear when it's an amber type of color. So, just to clarify. Okay, this right here is a diagram of how sucrose breaks down into glucose, and glucose breaks down to make the caramel compounds. So first, we have sucrose, which breaks down into glucose and fructose upon hydrolysis and heat. In step 2, the glucose and fructose transforms into fragmentation, and the fragmentation breaks down into our caramel compounds, which is our physical state at the end of our caramelization. Okay, so to conclude, my caramel didn't come out as I'd like to, but that's okay. We still got to see how chemistry was incorporated into making caramel, and we still got an educational lesson from this. I'll definitely learn my lesson next time. But yeah, I hope you guys learned something from this and you don't make the same mistake as me and you follow the steps correctly. Don't burn, don't overcook your sugar. But yeah, I hope you guys learned, and thank you so much for listening to this video.